Topic 7, Class 2. This is our first section of trigonometry. In the previous class we were looking at the trigonometrical ratios. Now we're going to look at what happens when the angle is greater than a right angle. And what we need to think about is that here is where we've been looking at the angles so far. So we could put our right angle triangle in there, and that's fine. That's between 0 and 90 degrees. But leave that there. But we also need to consider round to 180 degrees, to 70 degrees, and then back to 360 degrees. And we talk about these as being quadrants, and we name them again, matching the way we measure angles as going anti-clockwise. We call this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, some textbooks use ordinary numbers. I just tend to use Roman numerals, that's fine. So we're going anti-clockwise. Occasionally we might want to go the other way, but mostly we're going anti-clockwise. As a comparison, let's have a look at this. We could go that way, all the way around to here. If we're going anti-clockwise, the angle is 300. If we're going the other way, it's only 60 degrees. And we use the minus sign not to actually measure that it's some negative length. It's just that the angle has gone backwards, and we would still be talking about a triangle in there, just where the angle has been measured backwards. You can't have a negative angle. It doesn't exist. It's like a negative length. Similarly, we could go around that way and call it 240, or we could go around that way and call it negative 180. Again, the negative simply indicates the direction. We could think about this idea in terms of projection. We could talk about x as being the projection, or the x projection of OC. OC is the angle that gives us theta. The x projection is OB, and the y projection we could talk about as CB or OA. In the second quadrant, the x projection is negative, and this will have some bearing, as you'll see in a minute. In the third quadrant, both of the projections are negative. Now, let's have a look in quadrant 2. So this is in quadrant 2. The sine of the angle is going to have a positive x over a positive. The hypotenuse is always going to be positive, so it's positive over positive. The cosine is going to be, now in here the y projection is negative. So the cosine is going to be the negative length over the positive length, which is a negative number. Tan of theta is going to be the positive y. Oops, did I see? That's not what I meant to say. That's the x projection. The tangent of theta is the positive y over the negative x, which gives us a negative answer. In quadrant 3, we've got that the sine of theta is a negative over the positive. The hypotenuse is still positive. The cosine of theta is again negative over positive. And the tangent of theta would be a negative over a negative, which is a positive. In quadrant 4, we have same sort of idea. In quadrant 4, the x projection or the x length if you like, is positive, and the y projection or length is negative. So now we've got that the sine of theta is going to be a negative over a positive, which is negative. The cosine of theta is going to be a positive over a positive, and the tan of theta is going to be a negative over a positive, which is negative. Now, that means you need some way of remembering these. What I've done is I in my mind, I think of the positives, and I say that in quadrant 1, they're all positive. In quadrant 2, the sine is positive. In quadrant 3, the tan is positive, and in quadrant 4, the cosine. And I remember that as all science teachers count for some unknown reason. Now, we need to be able to use that, obviously. In diagram A, let's find sine of theta. Sine of theta is going to be, that length is 1. It's going to be 1 over root 10. Cosine of theta, now that's a negative length there, only negative in the sense that it's going backwards, so that would be negative 3 over root 10, and tan of theta is going to be 1 over negative 3, which we could just write as negative a third. In diagram B, sine of theta is going to be, now sine, there's our right angle triangle there. So our sine, our opposite is going to be, sine is going to be negative 5 over root 29. The cosine of theta is going to be negative 2 over root 29, and the tangent is going to be a positive number. It's going to be negative 5 over negative 2. The third example, C, let's find sine of theta. Sine of theta is going to be, so this is a negative projection down here. It's going to be negative 3 over root 18. The cosine of theta is going to be that one. And the tangent of theta is going to be negative 3 over 3, which is, whoops, negative 1. So in summary, you can see what I've just said. If you like to learn it this way, that's fine, or you can learn it as all science teachers count, or some other acronym.